What was the second learning objective? Probability, expected value and standard deviation. This is something you already know. We have already done that when we did the capital asset pricing model. So what we are going to talk about is only, what should I say, repeat of what we said. You said what are the three things? Probability, expected value, standard deviation. Fine. So we'll go to the second learning objective, probability, expected value, standard deviation. You have learned from your class 11 onwards somewhere, what is probability? Chance of occurring or, okay, well let's go put that out. Probability means the chance of occurring or non-occurring of an event. I'm not making technical distinctions about what is event, what is outcome. Statistical guys make all those distinctions. I'm not saying all that. We are just using it in very, very broad language. Okay. So the probability of India winning is 30%, India losing is 20%, something like that. What was the second term? Expected value. Okay. Now, when I say this is 70 and I say the probability of is 0.3, when I say this is 80 and the probability is 0.7, what do we normally do as we learned in the asset pricing model? 21, 56. What you said weighted average, perfect. This is 77. This 77, which accounting guys call weighted average, is what in finance referred to as expected value. Now I want you to understand that 77 is a number that will never happen. This guy will either get 70 marks or he will get 80 marks. Okay, so we must understand what is 77. 77 is that in the past, 3 times out of 10 he got 70. Okay, in the past 7 times out of 10 he got 80. If you add all this, the total is 770 and its average is 77. Okay. We are only saying what was his average mark in the past. That is why I don't like the word expected value, because expected value misleads. Expected value gives you an impression that you are likely to get 77. No. Expected value is just a number which will help us compare with another number. We are going to get only 70 or 80. I'll later give you another example. We are only going to get either 70 or 80, let us say, because 70 and 80 have a 1 probability. So there is no other number that is possible. We then say 77 is expected value. It means that based on the past, or in the past 3 times we got 80, 7 times we got 80. So on average we got 77. Okay, this needs to be understood. So let us go put out point number B, expected value. We'll just write a formula, I think that should be fine, or we can say, we'll say weighted average value. Expected value is the weighted average value with probability of occurrence being the in weight. Okay. Then next line you write the formula. Expected value is equal to sigma what? 1 to n P into R. Okay, sigma 1 to n P into R. So we have picked up what is expected value. Now we'll have to lay down our decision rule. Okay. Now the decision rule works like this. I don't know whether I gave this example earlier. Even if I had given it, we will repeat that example now. Okay. The decision rule is based on this. Between 2 alternatives, which one will you select? The one with the lowest expected value? Higher expected value. You will select the one with the higher expected value. Other things remaining the same. Other things here are risk. Okay, there are 2 things. One is return, the other is risk. That is why we have called this chapter capital budgeting 2, because it is the other phase of capital budgeting, other side of capital budgeting. Okay. Now let us take a quick example. Let us say somebody has to go to Hyderabad for an interview. Okay, let's say ITC hotels are conducting an interview, and any other hotel company that you know, or any other good company that you know where you want to work? You want to work in a hotel company? So tell me a company in which you want to work. Good company. Apple. Okay, wonderful. Where is this Apple's interview going to take place? California. They'll fly you from here, in a chartered flight. Tell me, tell some place. Bangalore. No, let's say Mumbai. We'll drop ITC. Any other company that you want to work? Google. So in all these companies, you should work what Apple does and what Google does. If you go and do, accounting standard there, it may not work. Anyway, it doesn't matter. Hyderabad, Google. Now that you have set your priorities or site at the right place, Google and Apple, how much salary Google will give you? 10 lakhs. No. Just tell one figure. 12 lakhs. What is the probability you will get 12 lakhs? No, 12 lakhs per annum, not per month. He's saying 12 lakhs per annum. It's not zero. Yeah, how much is the probability? You said 12 lakhs. He's insulted you, so you tell me. 0.6. Okay. Now this zero, how much will you get here? There is also one zero possible. I agree with that. 0.2. What is the other 0.2? How much you want? Anybody who is desperate to work in Google? 8 lakhs. What is the expected value? Don't need calculator for all this. Just multiply 7.2 plus 1.6. 8.8. Are they going to give you a check for 8.8 at the end of the year? No. They are either going to give you 12 lakhs or 8 lakhs or they are not going to recruit you. Okay, that's the meaning of zero. Mumbai, Apple, how much? 15 lakhs. Why? What are you going to do? You are going to create the new iPhone or iPhone 11? 15 lakhs. Okay, all right, take, whose problem? Then 5 lakhs. Good, I like that number. What is the probability of 15 lakhs? 0.3. 5 lakhs? Can't be 0.8. 0.4. I want one more number. Not zero. 2 lakhs. Hey, this is not in dollars yet, this is in rupees. 9 lakhs, okay. 9 lakhs. I'll change these figures because I don't like these figures. 0.3. What is the average? How much? How much? 9.2 is it? Then take 11 lakhs here. Now how much is it? 8. Correct? Theory tells us we must select this company. That means if both the interviews are at the same time, both of them on the 25th of March 2000 whatever, and both of them are at 11 o'clock and you can go for only one of these two interviews, theory tells us that we should go to Google for the interview. Why? Because it has a higher expected value. Many of us will go to Apple for the interview. Why? Because there is a certainty of getting a job. So we should not mechanically say I will select the alternative with a higher expected value. That is why economists have this wonderful starting phrase, other things remaining equal or other things remaining the same. They don't know what are going to be the same. Wait, other things remaining the same, the alternative with the higher expected value should be selected. Here other things are not same. Here the risk is less. Risk not measured by the way of standard deviation. Everybody can have a different way of measuring risk. Here risk measured in terms of whether I will get the job or whether I will not get the job. So let us go put out decision rule 1. Other things remaining the same, comma. Other things remain the same, comma. The alternative with the higher expected value should be selected. The alternative with the higher expected value should be selected. Okay. Now, since we have already read standard deviation, the capital asset pricing model, otherwise I would have chosen to do some questions on expected value and then go to standard deviation. Since we have done expected value earlier, since we have done standard deviation earlier, my suggestion is that we'll go ahead and finish off standard deviation also. What is standard deviation? We said a little while earlier. What was that? Deviation from expected value. Deviation from expected value. Now, in that example that you gave, in that example that we first wrote, the highest mark was how much? 98. Lowest mark was 40. That means somebody can either get 40 or he can get 98. He can get either 40 or 98. Okay. On the face of it, this is a wider breadth than, let us say, 55 to 80. Okay. This is prima facie less risky than this. Risky in the sense the width is very high. Here you can range from 40 to 98. Here it is only 55 to 80. But something like this indicates that there is equal chance of 40 and 98 happening. Then that is right. Okay. Then this is less risky than this because this is 40, this is 98 and the equal chances of happening, which means that the average is 40 plus 98 by 2, that is about 70, or how much is it? 71. This is 71 and here it is 62. Okay. But if there are many such numbers, many of them clustered here or many of them clustered here, the average will not be 71, the average will be different. Now we want to know how far away from the average these numbers are. That is what standard deviation measures, because the further away the numbers are, there is more risk. The closer the numbers are, there is less risk because there is greater possibility of predicting. That said, you know, since we have already just now written that standard deviation is what? Deviation from expected value. We'll not write arithmetic means, though that's what textbooks write. Then we'll put out the formula which you already know, sigma 1 to n PD square under a square root. So go ahead, write that formula. Standard deviation is equal to sigma 1 to n PD square under a square root. Okay. Now, if we found out the standard deviation in the 10 marks that we wrote, let us say that number came some figure, I don't know what figure. Let's say it came to 16, let's say it came to 64. What does 64 indicate? First of all, what is 64? Is it kgs or liters or tons or what is it? Marks. So whatever on which you are computing standard deviation, that will be the unit of measure for standard deviation. If you are computing standard deviation on 15 items that have kgs, the resultant answer is in kgs. If you are computing standard deviation of items whose unit of measure is miles, the resulting standard deviation answer is in miles. That's important to know. Second important thing is that sometimes there may be no probability. If there are no probability, there are two choices. One is you can assume a probability and work. Okay. One is that you can assume a probability and work. Two is that you can use a formula. Sorry? That's what uniform probability or equal probability. The second alternative that we can do is, we can say sigma d square divided by n under square root. Both of them will give the same answer because the probability here is uniform, which means the same number. So we can use this formula and get. Now, in technical parlance, there is a third one. It's sigma d square divided by n minus 1. Okay. When we work out the questions, we'll work out. It is sigma d square by n minus 1. What it implies is that this one is normally worked on a population, this is worked on a sample. But we don't have to worry too much about that because our questions, at least in the CA Institute, have not centered around it. Okay. They have not said this is sample, this is population. So we'll stick to this and work our answers. Okay. Now, keeping this in mind, I want us to know there's a last thing to do. Risk of one is 74 marks, risk of other is 65 marks. Which one has less risk? 65, which means the alternative between two alternatives, the alternative which has the lower standard deviation must be selected. So let's put out decision rule number 2. Other things remaining the same, the alternative with the lower standard deviation should be selected. The alternative with the lower standard deviation should be selected. Okay. If you want read this up.